We didn't have to change the amount of radiation that we exposed them to. So let's do another one. Let's say that your KVP is 60, and we want to increase it 15%. So 60 times 15%, what is 15% of that? 9. Okay. So we know that 9 is 15% of 60. We're going to add it to there. So our new KVP would be 69. So that's how we would adjust it for that patient. Now also in the book it tells you if you decrease KVP by 15%, it's the same as cutting the MAS in half. So it would be taking this number and going down 15% would be the same as if we cut this in half down to 5%, to 5 MAS. So if we do 40 again, we said 40 times 15% was 6, right? This time we're going to subtract it from 40 because we're decreasing it by 15%. So 40 minus 6 would be 30. No, it wouldn't. 34. All right. Then the other one we did was 80. We did 80, right? 80 kVp. So change this to 80. 60. Okay. Change it to 60. We said that was 9. So if we had 60 kVp times 15%, that was 9. We subtract it. 51 kVp. So you just got to read the problem, and if it tells you to increase it by 15%, you find out what the 15% is and add it. If it says decrease it, you find out what the 15% is and subtract it. And it's as simple as that. Okay, so we have the notes for week 3. All right, on the first page, it first starts talking about reasons that you would need to retake or repeat an x-ray. Okay, you take an x-ray of somebody and you have to redo it. Okay, there's several reasons that you might need to redo it. It says the 3 main reasons is operator error. That's you. In other words, you did something wrong. Maybe you didn't put the patient in the correct position. Like when we're doing the lateral of the knee or the lateral of the ankle, you might have them turned on the wrong side, something like that. Patient movement is another reason. You have to tell the patient to stay still when you walk away from them. If they move after you walk away, then they've changed the position, and then if you actually hit the button to take the x-ray, then it's not going to be the right x-ray. And equipment failure, something wrong with the x-ray machine. And a little bit we'll go over a couple of things that could be wrong with the x-ray machine. Also, if you don't put the right exposure factors in the machine, if you don't put the right KVP, or the right milliamps, the right time, or the right distance. Remember the distance? What's the distance supposed to be for the x-rays that you do on the table? 40 inches. Okay, so those are the kind of things that can make you have to repeat the x-ray. And you don't want to do that because you're exposing them to twice as much radiation. And you want to try to avoid that. So we're going to go over some of the problems that you can have with the x-ray machine, the equipment failure. First of all, it can be something electrical. All right. You have, remember from last week, you have the different circuits in the x-ray machine, like the MA circuit, which was called the the filament circuit and the high voltage circuit, there could be problems with basically the electrical system. And here on the notes in the middle, it tells you what you could see that would tell you that something's wrong. It says when an exposure is made, the MA meter should only move to the MA that was selected. Okay, so if you selected, let's say 100 MA, the needle is supposed to move up to 100. All right. If the needle kind of like bounces back and forth instead of stopping, then you know there's something wrong with the X-ray machine. Usually this means that it's lost the vacuum. Okay, remember, inside the X-ray tube, everything is surrounded by glass, and it's sealed up so that there's no air in there. If it cracks, if it gets too hot and cracks, then air gets in there, so it's not really a vacuum anymore. It says if your film turns out to be too dark, that means it could be the MA setting or the timer. Okay, this is sort of like baking a cake for too long, or baking it at a much higher temperature than what you're supposed to. So you think you're setting the machine for 50 milliamps, but it could really be reading 100 or 150 because the X-ray turned out to be too dark. If it's too light, okay, it could be the rectifier. Does anybody remember what the rectifier is? Well, that's part of it, but also in the generator, the rectifier is what changes the alternating current to the direct current. Okay? So remember, the direct current is what you need to get the X-ray tube hot enough. So that could be a problem, and that will cause the pictures to turn out too light. So really, you just kind of have to look at the X-rays that you're taking. If they're all coming out too dark or too light, then there's a couple of tests that you can do to try to figure out what the problem is. And the first one is called the spinning top test. And all of this starts on page 89 in the book. All right, for the spinning top test, you just take an X-ray cassette with film in it, and there's a top, just sort of like those little toys you used to have. You spin it, and it spins around. Well, you put that top on here, and it's got a little hole in it, and then you just spin it and you take an X-ray of it. And after you take the X-ray, you're going to see a circle on your X-ray film, and it's going to have some dots, because this little hole, as it spins around, it's going to allow the radiation to pass through the hole. So you basically look at your X-ray and see how many dots there are. And there's a picture, similar to this in the book. So depending on how many dots you have on the film, that could tell you what's wrong with the X-ray. So here in the notes it tells you, it says if there's exactly 12 dots, the timer and the rectifier are working fine. Okay, so 12 is the magic number. That's what you want it to say. What does it say if you have 6 dots? Genesis. Right, if you only have 6 dots, the rectifier is bad. If you have fewer or more than 12 dots, then the timer needs to be adjusted. So you have to memorize those numbers basically. 12 dots, 6 dots, or any other number besides that.